I'm going to try doing that, right? So, yeah, I'm going to record a little tutorial, see if we can share it on YouTube or something. All right, so you can see this, right? You can see the screen. So this is a pottery company, and they seem to be making bowls and mugs. And in this case, and I like this because the information is kind of concisely, summarized for us in a table. Because sometimes you see those problems where they explain everything in words. By the time you read the end and you start the problem, by the time you reach the end, you're lost as to what they're telling you. But in this problem, they seem to summarize everything on a table for us. So they're telling us that, okay, they're making bowls, mugs, and well, when it comes to, okay, the 1 hour of labor is required to make a bowl, while 2 hours of labor is required to make a mug. Well, the things are made with clay, so 4 pounds of clay makes a bowl, 3 pounds of clay makes a mug. And they're telling you that you can make $40 profit from a bowl, $50 profit from a mug. I think they later on explain how much labor is available, right? And how much clay is available per day, I think, right? So let's see, I think go down. Good, yes. So here you have 40 hours of labor per day. Sound like about 5/8, about 5 people working at this place. And they have about 120 pounds of clay available per day, right? So we declare some variables. We're letting X subscript 1 be the number of bowls they can produce per day. X subscript 2 is the number of mugs to produce per day. Notice that they use X and Y in this case, right? They use X subscript 1, X subscript 2, right? And the more advanced textbooks do this kind of thing because they would have X subscript 3. They could have a fourth variable X subscript 4. But sometimes you go with X, Y, and Z, and when you read Z, and let's say you have a fourth variable, you don't know what to do. So some books adopt this thing where you can have X subscript 10 now, right? Good. So, well, they start with the objective function. Z is equals to $40 times how many mugs you are. Is it mugs? Mugs and bowls. Which one is X1? Yeah. Bowl. So $40 times how many bowls you make, which is X subscript 1, plus $50 times X subscript 2. You don't have to use a dollar sign in the problem, but this particular author did it, right? And Z, this objective function is the profit function. And as always, in a business, you want to maximize profit. So you're looking in this whole problem to maximize Z, but there were some constraints, right? And notice the constraints. The number of hours of labor for the making of X1, I'll say X1, even though I'll drop out the word subscript, right? So you need 1 hour of labor for a bowl and 2 hour labor for a mug. So if you're making X1 bowls and X2 mugs, the number of hours will be 1x1 plus 2x2. And the labor, right? The number of hours should not exceed 14. That's how you write it, right? You don't have to write 1x1. You can write x1, right? Plus 2x2 must be less than or equal to 40, right? That's a constraint. You only have 40 hours of labor to make X1 amount of bowls and X2 amount of mugs, right? There's also another constraint. There's only 120 pounds of clay available. So, since bowls take 4 pounds of clay and mugs take 3 pounds of clay, then 4x1 plus 3x2 must not exceed 120, right? And then there are those kind of basic constraints, right? X1 must be greater than or equal to 0. X2 must also be greater than or equal to 0, right? It's a usual thing. Because, you can't run the factory and just make one product. You make all two, right? Because of demand and, all kinds of things. But sometimes you might very well, okay, let's say you say, I'm going to only make bowls. Well, there are people who are exports or who are there to make mugs. What are they going to sit down all day? So you'll make both of them, even though the bigger profit lies with mugs. Good. So with all of this information now, I think in the next slide, they summarize it all. This is all of them. And our next step now is to graph these here. We want to graph these inequalities, right? So the writer actually graphed them for us here. So 1 second. So this is the first one, x1 plus 2x2 equal 40. And as I explained in the video before, no need to do this by hand. You can use Desmos, right? You just type in x1 plus 2x2. You put less than here, right? Put less than or equal to 40, and Desmos will graph the thing for you. And it will color the region that satisfies the inequality. And I think it's going to be below the line, right? It's going to be below. And I think I told you before, in the video before, how to know that the region below this line satisfies this inequality. If you take, let's say the origin is 0, 0. You put it in this thing here. So you'd have 0 plus 0 is less than 40, which is true. So the fact that a point chosen at random below this line satisfies the inequality, well, then that entire region below the line satisfies the inequality. You do the same thing for 4x2 plus 3x2 is less than 120. You do that. Let me go down to that. That's this one here, right? Combine the two on one graph. This is it on one graph, right? As well, x1 is greater than 0 is actually the y-axis, right? Or the x2 axis. And x2 greater than 0 is the x-axis or the x1 axis in this case. And this is the region that satisfies all the inequalities. This shaded, this light blue region here. What they call the feasibility region, right? Now, any point in this region, you can put in the z function, right? But remember, you're not looking for just any point. You want to maximize z, right? And what this author did, he actually tried different values. And what you will find is that the maximum value of z occurs at one of these points, either here, here, here. Well, it can't be here, definitely the origin, right? So it's either this point here, this point there, or this point here, right? And they actually fool around. Let me just show you what they, just to show you that at this point here, at this particular point here, is where Z has its maximum value. So if you were to go up, so this is the feasible region. And if you were to try like this point S, this point T, right? you might get a very large value for Z, but remember, these points are not within the region that, kind of takes care of the constraints, right? Remember certain conditions about how much clay, how much labor is available. So if you choose T or S, you're not going to work or operate within the constraints of this manufacturing business. And therefore, there will not be a solution, right? You might have a very large number of Z, but they're not going to be within the constraints that were given, right? So what this writer did, he took the line 40x plus 50, 40x1 plus 50x2. This is the line here. And you can take any point here, right? What point did he choose there? Trying to figure out what point he chose. They didn't see. All right. But he tried different values, different values. So when the line runs here, he took a point here. When the line run here, he took a point. And when the line run out here, he took a point. And he got these values, 1600, with this line, 1200, 800. But what you will find is that, okay, when he took a point from the line here, it's this. When he took a point from here, it's 1200. When he took a point from this line, which is outside of the constraint, right? Well, that one definitely is invalid, the 1600. What you will find if you were to do this experiment on your own is that if you were to take this point exactly at B there, right? Exactly at B, and I think to read off that point, yeah, the point B is 24, 8. If you were to take those two values and put it inside the Z value, you will have the maximum value of Z subject to all these conditions here, these conditions about labor and how much clay and so is available, right? So when you put x1 equal 24 and x2 equal 10, you will get, I think, how much do you calculate? You get it 1200, yeah. You get it 1200. No, not 1200. You get, 1360. And that is the maximum profit you can actually achieve given these constraints. And the amount of bowls and mugs that you will produce will be what? 24 bowls, 8 mugs. Right? I'll do one just now where I actually go on Desmos, and maybe you will have a chance to do some calculations on your own. Right? So give me a chance. I'll stop sharing here. Right? Stop sharing here. And I'll open another example where they didn't give you the graph. We're going to come up with a graph. Are you able to follow that particular example? No, I didn't say nothing.
Sir, for me personally, I think so.
All right. Look at the second one. This one we have to actually do the graphing and so on. So here it is. Somebody's manufacturing printed circuits. Right? These electronics. Sometimes you open up any gadget you have, you see a little board, circuit board, and they have a whole set of components on them. So, okay, this circuit board has to have resistors, transistors, and capacitors. So they have 200 transistors, 200 resistors, 120 transistors, and 150 capacitors, right? The type A circuit requires 20 resistors, 10 transistors, 10 capacitors. Type B requires 10 resistors, 20 transistors, 30 capacitors, right? They even give you the profit for each circuit. You make $5 on circuit A, you make $12 on circuit B. They're asking how many of each circuit should be produced in order to maximize the profit, right? So if you take all this information and you actually will have to form the inequalities, right? I think there's some other constraints. Okay, you have a maximum of 200 resistors, 120 transistor, 150 capacitor, right? So let's see how we can put all those as inequalities. Good. So you start off with saying, let X be the number of type A circuits, let Y be the number of type B circuits, right? So, all right. So you need 20 resistor for type A and 10 resistors for type B. So in total, all the resistors will be 20X plus 10Y. That must not exceed 200 because you only have 200 resistors, right? So this expression here, 20X plus 10Y, must be less than or equal to 200. That's your force constraint. Second one, they'll go to, what was it? Transistors. 10X plus 20Y must be less than 120 because you have a maximum of 120 transistors, and similarly with capacitors. 10X plus 30Y must be less than 150. And then, these, what you call non-negativity constraints. X got to be greater than 0, Y got to be greater than 0. And this is your profit equation. So, well, one of the things I want you to do now, if you can write down these somewhere, because I want to go over to Desmos to plot them, right? I want to go over to Desmos to plot them. Is anybody writing? Please write them down because I'll ask you for them when I go over to Desmos. Got it? You write it down for me? So I'm going to stop sharing. I'm going over to Desmos now to plot them. So these are your. Can you tell me the force inequality we had there? Somebody can tell me? Yeah, I don't know. Hmm. let me see if I can copy it here. Control C, Control V. It's not, nobody didn't write the thing no. 20x plus 10y is less than 200. 20x plus 10y is less than 200. That's it there. Um, 10x plus 20y is less than 120. 10x plus 20y is less than 120. And then finally, what's the third one? 10x plus 30y is less than 150. 10x, 10x plus 30y is less than 150. So these are our inequalities. And it's in this region here, let me try to see if I can. This is the feasibility region, really. This here, right? Come down here, come down here, come down here, go up back there, right? That's the feasibility region. Now you got to get these points here, right? These points here, here, there, right? Let's see how we can get it. I have to erase everything back. Let me go back. So this point is 0, 5. This point here is 6, 3. It's this point, not that one, not that one. This one here. Uh, that one here. Good. So um, a few of you are still with me. So if we were to try these numbers in our Z value, right? Our Z value, what's our Z value? Let me see if I can. Not Z, it's P in this case, 5 and 12. 5x plus 12y. All right. Yeah. You need to try this value in our P equal 5x plus 12y. Right? So if you try 0, 5, well, remember 0, 5 doesn't actually satisfy the constraint. You can't have x nor y. I think you can have them 0, yes, but yeah, they wouldn't give you a maximum. You may, if you use 9 and 1, I don't know. Don't use 0.33 because you can't have 9 and 1 third of a circuit board. How are you going to sell that? Nor can you sell 1 and 1 third. So um, try them in your p-value here, your p function here and tell me which one will give us the maximum. Y'all are with me? Try it while I'm... So if you were to try, I'm not going to waste time using the 0 and 5 nor the 10 and the... let's see. That is 0 and the 5. Because 12, 5 will be 60. That wouldn't maximize nothing. So let's go with the 6 and the 3. So 5 times 6 plus 3 times 12. That'll give me 66. Right? 66. Let me try the 9 and the 1. 5 times 9 plus 12. That's 57 only. And if you do the 5 and the 10 and the 0, you got 10 by 5 with only 50. So your p-value, your p function is going to have the greatest value when you have x equals 6 and y equal 3, right? This point here. And that is going to very well give you your maximum value for p, right? So y'all follow this one? So you can, for you to be able to maximize profit and at the same time satisfy all the conditions, right? Because you have a limited amount of resistors, transistors, capacitors, and so on in the manufacturing of your type A and type B printed circuits. So for you to maximize your profit, you'd have to produce 6 type A circuits and 3 type B circuits. Right? Anybody with me still, or everybody gone?
So I think I understand that one.
Okay, yeah. So you know, please learn to use Desmos, or if you want to go and use GeoGebra, there's another program named GeoGebra. Some people use another program in Symbolab. Some people use it. There's one in Wolfram Alpha. Find some graphing program. That's what I'm saying, right? Find a graphing program, right? And learn to use it to plot these, because you can't plot these with your hand in a test, you know? It'd be difficult. And to read off the points, and so it's going to be difficult. And you can't solve algebraically maybe the 2 lines and to get x and y, and so it's going to be a lot of work for you. So make sure you have a good program that will do this thing fast for you. This morning, a girl actually took out this point. Just to highlight this, I think we had a blackout and the class, this point here. See where the pencil is? Look here. And that point is 9-2. And she was saying why we can't do work with 9-2. But 9-2 is outside of the feasible region, if you notice. You see this blue line coming here? Below this blue line is the feasible region. So 9-2, while it's a nice round number, it doesn't fit in. It's not a point within the feasible region, meaning it doesn't satisfy the constraints, right? And therefore, you couldn't use 9-2 even though it's round and nice, and it will give you a very large value, a larger value, in fact, for P, because check 9. 5 9s is what, 45 plus 12 2s, 24, let's see. 45 and 24. Just want to see that. Okay, clear. 45 plus 24. 69, yeah. It does, yeah, it does give you a higher value than 6.3. But remember, 9.2 is not within the feasible region, and therefore you just can't use that, right? You just can't use that. All right, so I'm not gonna do any more examples. I'll try tomorrow if we have power. I'm gonna record maybe another 2 examples, not these same ones. Maybe I'll try another 2 and add it to this video so you have more examples at your disposal. Of course, don't forget, well, I made that video with a couple of examples. And then you have YouTube as at your disposal and so many other places that you can go and type in, right? If you probably type in linear programming, some of them will bring up something called the simplex method, which I will show you next week. It's by no means simple, right? You might have to look at graphical approach to linear programming, and you can have endless videos there that you can watch and learn from, right? So make use of those, so that you see so many of these examples. You can even try the questions, right? Try the questions. I think I sent one this morning. That was the group that we had a blackout. I think it's the same question, and we had to abort or something like that. I can't remember what happened, but I sent it on the group, right? But here it is. It's worked out for us. Good. So